All right, this section is going to cover two different things, talking about what to do if you have two different rational expressions. And what I mean by that is two things that are written as fractions that include more than just numbers. So how do you handle, or even regular fractions, I guess, because there are a lot of fractions that you have to do by hand in calculus. But how do you add and subtract rational expressions? And then also, what would you do if you were solving a rational equation? If this was Honors Math 3 or Honors Pre-Calc, I would be very consistent with how I did this, and I would do it exactly the same way every single time, whether or not it was quicker. Since this is calculus, I'm going to assume that you can kind of roll with things a little bit better, and we're going to be flexible in our approach. That's kind of how we do things. I guess at this point, I'm assuming you're good enough at this algebra that you can be lazy with your approach and do a few different avenues, depending on which one's quicker, basically. So here we're going to solve these because they are equations. So that's what the instructions are going to say. But I am going to show you a couple different ways of like how I would do the problem depending on what it was. So this one starts off with 1 over x minus 3 plus 1 over x plus 3 equals 10 over x squared minus 9. And so first I'm going to say, let's just ignore the right side of this. Let's pretend that we needed to add these rational expressions right here. So if this was not an equation, this was just a problem where you had to add them, then you would need to have a common denominator. And so your common denominator would be the x plus 3 and the x minus 3. And so that would tell you that for the first fraction, you need to multiply by x plus 3 over x plus 3. And that for the second fraction, you need to multiply by x minus 3 over x minus 3. And the purpose of doing that is to get that common denominator. So at that point, you would say, I've got x plus 3 over x minus 3x plus 3 plus x minus 3 over x plus 3x minus 3. And then I could go ahead and I could add those together and say x plus 3 plus x minus 3 is just 2x. And on the bottom, at this point, I could leave it as x plus 3, x minus 3, or I could say I want it to match the right side of the equation. I recognize that those are the same, so I could say, oh, those are, x squared minus 9, 10 over x squared minus 9. Okay, so that's one approach you can take when you're solving a rational equation now, is to have the left side and the right side have that common denominator. At the point where you have a common denominator on the left side and the right side, you can kind of ignore that you have a denominator. So you could just say 2x equals 10, solve for x, so I'm going to divide by 2, x equals 5. When you're solving a rational equation, you just have to make sure that plugging in 5 for x is not going to give you an extraneous solution. So 5 minus 3 is not 0. We can't divide by 0, so that's good. That doesn't equal 0. 5 plus 3 doesn't equal 0. 5 squared minus 9 does not equal 0. So this is a good solution. It's not extraneous. All right. Now, if this problem was an equation from the beginning, which it clearly was, but I didn't treat it like that. If this was me and I was doing this problem from the beginning, then what I would have done instead is I would not have gotten this common denominator and done it the way I did it. I would have said, let me take this entire equation and multiply it by the factors that were needed to make the common denominator. So I would have said, okay, this is an x minus 3, so my common denominator needs that. That's an x plus 3, so my common denominator needs that. And then I would recognize over here that x squared minus 9 is actually the FOILed version, I guess, of those two factors. And so then what I would have done is I would have thought about taking these and distributing them to each piece. So when I multiply this stuff to the 1 over x minus 3 over here, that x minus 3 and this x minus 3 cancel, and I end up with a 1 times x plus 3. When I multiply these two by this one, the x plus 3 and the x plus 3 cancel, and I'm left with the 1 times x minus 3. And then when these two multiply by this last term, both of those would cancel with the denominator. This equals 10. And then I would get 2x equals 10, and then I would get x equals 5. So if the problem was just to do the equation, this way is clearly faster if you understand the math well enough to do it. If this wasn't even part of the problem at all, then you're forced to do all this work. So that's what I'm talking about, where I would maybe shortcut it a little bit if I was solving an equation, but if I was just needing to add or subtract the expressions, I would have to do all the extra. The reason I'm showing it to you both ways is I didn't want to make this two different sections in the packet. I just wanted to be able to show you both skills. So for the rest of the problem, I guess I'll do the way first. You're going to practice this method more in the next section. So I think for the other two examples, I'm going to show you this way because I think students sometimes have a hard time with this. And then you'll still get to practice this. But when you do it in your packet, whichever way you choose to do it is totally fine. All right, so example 2, we're going to have 2x minus 1 over x minus 1 minus 3x over 2x plus 1. And we have x squared plus 11 over 2x squared minus x minus 1. All right, so this is a good chance to practice some factoring. I'm going to factor this. I'm pretty sure it's probably those two factors, but I'm going to practice the factoring anyway in case you need it. So this, because there's a number in front of the x squared, would be a slide divide problem. So 2 times negative 1 is negative 2. So we're multiplying to negative 2 and adding to negative 1. So that'd be negative 2 and positive 1. So that means my two sets of parentheses are x minus 2, x plus 1. And then there's a 2 right here, so I need to go ahead and divide by 2, divide by 2. So that's going to simplify to be a 1. I've got an x minus 1 there. And then with this one, it doesn't simplify, so I'm going to go ahead and bottoms up. So I was right. It made sense. You know, those were the two denominators. Okay, so if we're going to get a common denominator for all three of these pieces, then this one needs the 2x plus 1. And then this one already has the 2x plus 1, so it's going to need the x minus 1. Do you guys like how I was inconsistent there with my parentheses? And then the right side already has everything. Because that was built from those two parentheses. Okay, so for the first piece, I have that common denominator, and you can write it in the factored form, or you can write it in the expanded form. Whatever way you write it is totally fine. So for the top, we do want to FOIL this though. So I'm going to say that's 4x squared plus 2x minus 2x, and then minus 1, minus. And then when I multiply these out, I'm going to get 3x squared minus 3x. And at this point, to make this problem feel a lot better, I'm just going to go ahead and get rid of those denominators. Now that they're all the same, I can do that. And then I'm going to show the rest of my work. Since I'm subtracting all of this stuff, I need to distribute that negative. So I'm going to minus 3x squared and then minus negative 3x. So when I subtract a negative, that means I'm adding. All right, so 4x squared and negative 3x squared makes x squared. But if I didn't have the x squared on each side, then this would have been a factoring problem. And you need to be really good at recognizing that because it happens all the time. However, those are just going to cancel out. You can subtract 1 off each side. So I've got 3x minus 1 equals 11, 3x equals 12, x equals 4. And then before I say that's my answer, since this was a rational equation, I need to go back and make sure this is not extraneous. 4 minus 1 is not 0. 2 times 4 plus 1 is not 0. And if it was okay for these, it's going to be okay for that one. And so there's my final answer. All right, and then one last example. 2 over k squared minus 4k minus 12 over 1 over k minus 6 equals 3 over k minus 6. Okay, so there's a couple different ways of simplifying a problem like this. If you would like, you can not watch the rest of this video, and you can look at the video for the next section and do it that way instead. Or I'm going to show you guys a different way how to do it from the next section. So this is kind of based on what you probably would have remembered a little bit from Math 3 or pre-cal, is that here we're going to go ahead and do keep it, change it, flip it. So I'm going to keep this part. And this right here is factorable, so I'm going to go ahead and do that as I do keep it, change it, flip it. So keep it, change it to multiplication, flip this part. And then over here, I'm going to go ahead and factor this before I write it down. So I'm looking for two things that multiply to a negative 12, but add to a negative 4. And the numbers that do that are negative 6 and positive 2. All right, so this is a different problem because we're not adding and subtracting fractions, we're multiplying them, and that's a much easier procedure. So I'm going to say that these, a k minus 6 on the top divided by a k minus 6 on the bottom, these are going to cancel out to make 1. So what I really have is 2 over k plus 2 equals 3 over k minus 6. Now how you continue this problem is up to you. If you want to do the option where we get a common denominator, you can do that. Or if you want to put parentheses around this whole thing and multiply to get rid of the denominators, you can do that. Or if you want to cross multiply, because anytime you have one fraction equals another fraction, you can do that. So you have lots of options. It doesn't really matter which one you do. So I'm going to go ahead and take this and multiply to get rid of these denominators because I like this process. I think it's a good skill to have. So when I multiply by this one, the k plus 2's cancel out, and I have the 2 left over as well as the k minus 6. And that gives me 2k minus 12. And then when I multiply by the second one, the k minus 6 cancels, and I'm left with the 3 times the k plus 2. And that gives me 3k plus 6. So I can get my k's to one side, minus these over, I get k plus 6 equals negative 12. Negative 18 equals k. And then I just need to go back and make sure it's good in all my denominators. This was k plus 2 and k minus 6. So if I think about plugging in negative 18 there, I'm good. If I plug it in here, I'm good. If I plug it in there, I'm okay. If I plug it in there, I'm okay. So k equals negative 18. And if you notice, this is actually exactly what you get when you cross multiply. See that?